Welcome to your video, Earthlings, on one-step equations. I am here because Miss Fallstick is on planet X, and in order to get to her, we have to talk about what X means. No, this is not Miss Fallstick with plastic surgery. I captured her. I think I'm going to talk in my normal voice. Alright, boys and girls. This is your video introduction on one-step equations. And X is something new that you're going to start seeing when discussing equations. So let's first look at our introduction. What do you notice about each of the following? If you notice, first of all, each problem has an equal sign, and each problem has two sides to the equal sign. If we are to simplify both sides, 6 plus 3 is 9, and this side has a 9. So 9 is equal to 9. On this side here, we have 5 plus 3, which is 8. And on this side, we have 1 plus 7, which is also 8. So on both of these number sentences, each side is equal to each other. I want you to take a look at this picture. This is a picture of a type of scale. In order to balance the scale, each side has to have the same weight or the same amount of items. If you put a turtle on this side and a planet on this side, it's going to be off balance. An equation is a balance between both sides of an equal sign. I also want to introduce to you another term called a variable. You'll start to see letters in math as far as solving a problem. So a variable can be represented as planet X. It could be Y. It could be Z. So a variable in math is what we call the unknown. It's a missing piece of information. So we're going to start off with our addition equations. My equation is x plus 2 on this side of my balance beam is equal to 5. I use dots to represent the numbers, and I want you to think, how many dots need to go in this box so that we have 5 on this side in order to balance with 5 on this side? So I have 5 circles here. I have 2 circles here. If I put another 3 circles, I have 5 circles on this side, which will balance out this side. So in this case, x is represented as 3. Because if I plug in 3 for x, 3 plus 2 is 5, which will balance out this side of the equation. I also want you to notice something else. If I take 5 minus 2, I get an answer of 3. So if I take 5 minus 2, I get an answer of 3, which is our x or our unknown. Let's look at another example. Some number or some unknown plus 4 has to balance to 6. So I have 4, and I have some number that represents my x value, has to balance to 6. So I have 4 dots on this side. If I add 5, 6, I've balanced my equation. I have 6 dots on this side. I have 6 on this side. And my variable x is equal to 2. 2 plus 4 gives me 6 in order to balance out my scale or my equation. Let's look at this example here. If you notice, my variable is on the other side of the scale. 3 plus some number has to balance out with 10. So I have 3 circles here. I'm going to add another 7 circles to balance out to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this case, h is equal to 7. Because if I plug in 7 for h, 3 plus 7 is 10, which would balance out with 10. Or if I do 10 minus 3, I also get 7. That's going to be an important piece of information. Okay, so this is a balance beam without the circles. Some number plus 1 has to balance out with 3. When solving these types of equations, as I proved in the last few slides, if you subtract this number to both sides, we'll get our variable. So my x value, I'll highlight in one color. My other term, I'll highlight another color. And the opposite of addition is subtraction. So if I subtract 1 to both sides, I will get my x value or my unknown. So x is equal to 3 minus 1, which is 2. If I go back and plug in 2 for x, I'll have 2 plus 1 on this side, 3 on this side. 2 plus 1 gives me 3, which will balance out to 3 on this side. Let's look at this example here. Actually, this one here. I have 5 on this side. I'm going to highlight my x term and highlight what's being added to that term. In order to find my unknown, I'm going to do my inverse operation of plus 4 and do minus 4, minus 4, 5, minus 4 gives me 1, which is equal to my unknown or my x value. Again, if I plug in 1 for x, 1 plus 4 gives me 5, which balances out my scale to 5 is equal to 5. Let's take a look at our graphic organizer. We have 2 examples. The first example says x plus 9 has to balance out with 15. Or some number plus 9 or added to 9 equals 15. In order to determine that, we're going to use inverse operations and do 15 minus 9. So I'm going to subtract 9. 15 minus 9 gives me 6. Therefore, x is equal to 6. On this example here, X is on the other side. So therefore, I'm going to do 23 minus 5. 23 minus 5 is 18. So 18 is equal to X. Or I can go back and say 18 plus 5 is 23, which would balance out my scale. Now let's look at these examples without the scale. So 10 plus some number has to equal 55. In order to determine that number, I'm going to do the opposite of addition, which is subtraction. So I'm going to subtract 10 to this side of the scale, and I'm left with X is equal to 55 minus 10, which is 45. So 10 plus 45 gives me 55. On this side, we need to balance out to 13. So 13 has to be balanced to some number plus 6 has to equal 13. In order to do that, we're going to use the inverse operation of addition and subtract both sides by 6. 13 minus 6 is 7, which is equal to my unknown. In these two boxes here, what I want you to do is come up with your own one-step equations with addition. And in class tomorrow, we're going to solve those as a warm-up. So you want to come up with, you can use any variable. You can use X, P, Q, T, Z, and I want you to create your own one-step equation in these two boxes. All right, boys and girls, I need to go rescue Miss Fallstick because I think she's doing too much math on Planet X. I know these are hard to solve right now, but they'll become easy, I promise. Goodbye, Earthlings.